Ladies and gentlemen, we're working on DMA 40 sections 3 and 4. In section 3, we are looking at various terms. As we're looking at terms, we need to identify, first of all, what is the coefficient of each term, and then we're going to determine if they are like or unlike terms, and we'll talk about why they are or are not. So in our first example, we have 7W and we have 4W. If I ask what is the coefficient of the first term, the coefficient is the numeral beside the variable. So the first coefficient is 7. The second coefficient for this one is the number 4. The variable for both of these is the letter W, just a single W. So if we're asked if they're like or unlike, we would say they are like because the variables are identical. In my next example, 5xy, the coefficient is the number 5 in the first term. In my second term, 5x, the coefficient is also the number 5. If we're asked, are they like terms or unlike, what we're looking at are the variables. One has xy, the other has a single x. So these would be considered unlike. They are not the same. They have to be identical. In our third example, 2ab, our coefficient is the number 2. Our second coefficient is -4. Our variables are AB and AB. They both have 1A, they both have 1B, so we would say these are like terms. In my last example here, 3x squared, the coefficient is a 3. In my next example, 3y squared, the coefficient is also a 3. However, when I look at x squared and y squared, true, they're both squared, but the base letter, the base variable, is different. So since they are not the same, these would be unlike. They are not like terms. Why is it important? You're wondering, why is it important that we know if we have like terms or unlike terms? What is the purpose of this? The purpose of this is in order for us to simplify an expression. Let's say we have 6x minus 10 plus 4x plus 7. If I were to have this as my algebraic expression and I need to simplify it, what I'm going to do is I'm going to combine like terms. So I would begin with 6x and 4x. Both of these have an x. I'm going to combine the coefficients. So 6 plus 4 gives me 10x. For the numerals, I have a -10 and a +7. So -10 plus 7 gives me a -3. If I have 18x squared minus 4 minus 5x squared plus 7. As I'm simplifying this expression, I'm going to combine like terms. So the 18x squared and the minus 5x squared are both like terms. 18 minus 5 leaves me with 13x squared. -4 plus 7 is going to give me a +3. So I have combined my like terms. Let's say I have -7 times 3x minus 6 plus 3x. Now, in this particular scenario, what do you think I need to do first? I have a parenthesis that we didn't have before. And remember how we learned how to use the distributive property. So -7 times 3x gives me -21x. -7 times -6 gives me a +42 plus 3x. Now I need to combine like terms. So I have negative 21 plus 3, and that leaves me with negative 18x. There is nothing else. This is left alone, so I bring down my plus 42. Let's try some more. So here we have, let me write this down for you. We have negative 3, 2x minus 5, minus 6, x plus 2. Okay, so the first thing we're going to do is distribute. This negative 3 is distributed with only the first parenthesis. Negative 3 times 2x is negative 6x. Negative 3 times negative 5 is positive 15. Negative 6 is distributed with these two. Negative 6 times x is minus 6x. Negative 6 times 2 is minus 12. Now, what I need to do is combine my like terms. So I have negative 6x minus 6x. Now let me show you something. If you're using your calculator and you have negative 6 minus 6, you can key that in and get your answer of negative 12. Let me show you a common mistake. Has anyone ever accidentally hit the minus key for a negative? If you tried to type in minus for a negative 6 minus 6, notice the answer that pops up here is completely incorrect. When I hit the minus key first, it popped up with ANS for. So as I just said, be very careful that you don't inadvertently use the minus key when you should use the negative. Always use this at the bottom. If the first value is negative, you would do negative 6 and then minus 6. So we have negative 12x, and then we have 15 minus 12, which leaves us with a positive 3. As we look on to section 4, this is the addition property of equality. With the addition property, what we're going to do is we need to balance out each side of our equation. As we balance out each side of our equation, what we do to one side, we have to do the same thing to the other. So, for example, if I were to have x plus 4 equals 9. If I'm trying to get a solution for what x is equal to, I look at what is on the same side. I need to move this adding 4 to the other side of the equation. So to make it cancel out here, I would use the additive inverse, which is a negative 4. That makes this cancel. And what I do to one side, I'm going to do to the other. So now I bring down my x, and 9 minus 4 is equal to 5. Let's look at a few more examples of this. If I have, let's say, x minus 10 equals 3, I need to move my minus 10 to the other side of the equation. So the opposite of subtracting 10 is adding 10. And then I'm going to add 10 to the other side. Bring down my x, and 3 plus 10 gives me a solution of 13. So with the addition property of equality, we are going to do the opposite of either adding or subtracting when we move from one side of the equation to the other. Let's look at another example. Let's say we have, and let's complicate this one a little bit. 6x plus 2 minus 3x is equal to 3 plus 2x minus 4. Now, I'm not going to start moving things across the equals until I combine like terms on the same side. So on the left side, I have 6x minus 3x. 6 minus 3 is 3x, and bring down my plus 2. On the right side, there's only a single 2x, so I'm going to bring that down. And then I have a positive 3 minus 4, which gives me minus 1. At this point, what I did first was, as I said, we combine like terms on same side of equals. Once you've combined those, now we can move from one side to the other. As a rule of thumb, I like to move my x to the left, so I'm going to subtract 2x on both sides. 3x minus 2x leaves me with a single x, plus 2 equals negative 1. I still do not have my x alone, so this plus 2, I need to subtract 2 to make it cancel here, and then I subtract 2 here. X is equal to, this would be keyed in as negative 1 minus 2. Let me show you. Negative 1 minus 2 gives us negative 3. That's a solution of negative 3. Let's try another example. Let's take what looks to be a more complicated one. You're going to find that these are really not difficult to do. It just takes learning the process, and we're combining like terms on the same side of the equals. So what we're going to do first on the left is we have a 13x and a plus 2x. Include the sign. So 13 plus 2 gives us 15x. Then we have a negative 9 minus 5. That gives us minus 14. On the right side, what we can combine is a 12x and a plus 2x. 12 plus 2 is 14x. The minus 1 is alone, so let's bring that down. Now, I'm going to move my 14x to the left. So I'm going to subtract 14x, which is the opposite, to make that cancel, minus 14x. 15 minus 14 is a single x, minus 14 equals negative 1. I'm now going to move my minus 14 by adding it. That makes it cancel here, so I'm going to add 14 to the other side. X is equal to negative 1 plus 14 is positive 13. Let's take this and let's apply it to a word problem. So we're going to apply this to a word problem. So what we're going to have is a 10-foot cord is cut into 2 pieces. If one piece is x feet long, express the other length in terms of x. 10-foot cord cut into 2 pieces. One piece is x feet long. Express the other length. If you need to, sketch yourself a picture. The total length of this cord is 10. It's going to be cut into 2 pieces. This is the first piece. This is the second piece. The first piece is labeled as, they want us to call it x feet long. What is the length of this? If I know that this much is x, and if I know the total length is 10, what operation can I do with 10 and the x that will represent the amount that is left? If we're not sure, I'm just going to randomly come up with a number. Let's say x was a 3. If x is 3, we all know that 3 plus 7 would give us 10, correct? So how do I go about calculating the number 7 using the values 10 and 3? I would say 10 minus 3 is equal to 7. So to come up with my equation, I'm going to have 10 minus x is going to give me the length of the second piece. So the equation they're looking for is just simply 10 minus x. I take the total length, subtract the length of the first piece, and that's going to give me the algebraic expression for the length of the second piece. Thank you very much.